Hello, welcome to my channel. In this episode, we want to provide answer to this question under matrix 3 by 3 matrix. So if 2x minus 1 x minus 1 as in the vertical column, x plus 7 6 x plus 1 x plus 4 2 and 3. This is the 3 by 3 matrix. So this is the determinant. We want to use the determinant of this. So if the determinant of the 3 by 3 matrix is given at what? 0, then what is the value of x in each of the entries? So for us to be able to find a determinant of 3 by 3, we know we break it down to 2 by 2 matrices using the plus, minus, plus for the first entry, the second entry plus, the third entry being what? Positive. So let's get started. So the first thing first, I'm holding the first entry. So that is going to be 2x minus 1, creating a 2 by 2 matrix from here, covering the row and the column. I'll be left with 6 x plus 1, then I'll be having 2 and 3, creating 2 by 2 matrix. After covering the first entry, the whole row and the column, you'll be left with only this. Then since I said plus, so this is plus, then minus, I'm using x plus 7, also multiply a 2 by 2 matrix, whereby if I cover the row, the column here, it means 6 and x plus 2, x plus 1 is gone. I'll be left with this and this, because this is going to cover. So I'll be having only x in the first entry, x minus 1 in the second entry, 2 and what? 3. So now let's take the last one, which will also be plus x plus 4, multiplying the determinant of the whole row being covered. This is covered, so I'll be left with only x minus 1, then 6 x plus what? 1, the determinant. Alright, what are we going to do now? We know it will be easy to find the determinant of 2 by 2 matrix. Multiply the leading diagonal minus the other diagonal. Leading diagonal minus the other diagonal. So still holding my 2x minus 1, then multiplying the leading diagonal will be 18 minus the other diagonal. Don't forget, it will be 2 times x plus 2 times 1. Since it's negative, I'll be having negative 2x, then 2 times 1 is what? Positive 2, but there's a negative in front, so I have what? Negative 2. This is the leading diagonal minus the other diagonal. Alright, let me re-explain this. It's going to be negative 2x plus 1. So negative 2 times x give us negative 2x. Negative 2 times 1 give us this. So that is what I mean by that expansion. Then this will be minus x plus 7, multiplying your leading diagonal will be 3x. Then the other diagonal will be minus. So still minus 2 times this will give us minus 2x. Minus 2 times minus 1 give us plus what? 2. Then right here we have plus x plus 4 multiplying. Our leading diagonal is going to be x times x squared. X times 1 will be x. Then we have minus. So right from there, you're going to have minus this times this. And that is going to be minus 6 times x. That will give us minus 6x. Minus 6 times negative 1 will be positive what? 6. Okay, so now what do? We need to expand the bracket further. Or better still, let's see if we can simplify the bracket. I'm seeing a constant and a constant. X power 1, x power 1. We can simplify. X power 1, x power 1. So let's see. Still holding my 2x minus 1. In this bracket, the 18 minus 2 will give me 16. Then minus 2x will be there. Minus your x plus 7. In here is going to be 3 minus 2. That will be what? 1. So it will be 1 of the x. Then plus 2 will come. Your x plus 4. In this bracket, we have only one x squared. So we maintain the x squared there. We are having x minus 6x. Meaning 1 minus 6. That will give us minus 5 of the x. Then we add our plus what? 6. So now we are having product of what? Binomial, then a binomial and trinomial. So we have to expand further. So we are going to use the full method, whereby 2x times 16 will give us 32x. 2x times negative 2x will give us a negative 4x squared. Then we take the negative 1. So negative 1 times 16 will be negative 16. Negative 1 times negative 2x plus 2x. 1, 2, 3, 4. Don't forget, a full method will give you 4 tens. Then here, we are going to have, let me put all these in one bracket. I'm going to introduce a bracket because the negative is affecting not only the x plus 7, but it's affecting the 2. After you expand, the negative affects all the terms in there. So let me have a bracket so that x times x will give us x squared. X times 2 will be 2x. 7 times x, 7x. 7 times 2 will be 14. So we close that bracket. So here x will multiply x squared. That will be x to the power what? 3 or x cubed. X times negative 5x will be minus 5x what? Squared. X will still multiply 6 to give us what? Plus 6x. That is using the x to expand. Now we use 4. 4 times x squared will give us 4x squared. 4 times negative 5x will be negative 20x. 4 times 6 will be 24. So we have plus 24. So in expanding the binomials and that of the trinomial, this is what we are going to have. And in each of the groupings, x to the power 1, x to the power 1 can be simplified. X to the power 1, x to the power 1 can be simplified. X to the power 2, as in this case, x to the power 1 could also be simplified further in order to make them become simpler. So permit me to claim the top. I believe to this stage, you are able to follow up to this stage. So I'll claim the top so that we can continue from there. Okay, so what do we do? We now add this and this together. That is going to give us 34x. So we're having 34x right there. Then I will still be having minus 4x squared. Then this will come as minus what? 16. I think we are done. It was 1, 2, 3, 4. It has reduced to 3. So now let's maintain our minus. Let me bring the bracket since we need that to be there. So 2x plus 7x will give us 9x. So I will maintain my x squared plus 9x. 14 will still maintain as plus 14, the bracket, as plus 14. So we close that bracket. Then plus in here, x to the power 3 will still maintain minus 5x squared plus what? 4x squared. I think it's plus, right? This and this will be plus. So let's have the plus there. So if you're adding that, that will be giving you minus 5 plus 4. That will be minus 1. So I'll be having minus x squared, then 20x, 6x. So positive 6 minus what? 20. I believe we have negative 14x. So negative 14x. Then the next thing will be our 24. So plus 24. Let's close that. All right. What can we do further? I believe in each of the groupings, we have a single term, which we cannot simplify again. So now let's open this bracket for the negative half effect on the terms in that place. So I'll be having 34x minus 4x squared, 16 minus x squared minus 9x minus 14 x to the power 3 x squared 14x 24. Don't forget there's no negative here, so we maintain all the signs of the terms in that bracket. All right, what do we do next? Now let's see how we can group like terms. Looking at it, power of 1, power of 2, power of 2, 1, 3, 2, 1. So let's bring the power of 3 first. So I'll be having x to the power 3 minus 4x squared minus x squared minus x squared. I believe 1, 2, 3. So let's go straight to minus 9x. Okay, I think this will come 34x minus 14x minus 16 minus 14 plus 24. Let's see the terms. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Beautiful. So now let's simplify them together and see. The x to the power 3 will still maintain. So now I'll be having minus 4 minus 1 minus 1. I believe these are all negative. We can still introduce them with plus. Introduce with plus. So minus 4 plus minus 1 plus minus 1. That gives us minus 6. In that minus 6, your x squared will come. This is going to be minus 9 plus 34 minus what? 14. Right here, we can have a negative number and a negative number. We can group them together. You have negative 9 minus 14 plus what? 34. Just as we did here, this will give us negative 23, I guess. Yeah. Then plus what? 34. This is less than this. We can subtract. So that will give us 11, right? Positive 11. So we have plus 11x. Then right here 16, 14, 24. So you have, I believe, negative 30 in this case, plus 24. This is bigger than this. So we have negative 6. So I have my negative 6 in here. So this is what we are going to have. So this is 1, 2, 3, 4, 4 terms. Whereby the highest power is what? 3. A polynomial with what? A degree of 3. Now, for us to be able to solve this, you can see from the beginning, or we have left out the 0. The whole determinant was equated to 0. So everything we are doing is all equal to 0. We are finding the left equals to the right, and the right is 0. So I will now introduce my word 0. You can carry it along as you are doing, but because of the space on the board, that is why the 0 is missing from the beginning. But now it reappeared. All right. So we are saying that all the left must be equal to 0. So for us to be able to see, it means the x can assume some certain number that will make all of these to be what? 0. And that number of x become the factor of this polynomial. So let's see if I use 1. 1 cube will be 1. 1 square 1 times this 6. 1 times this 11 minus 6. This gives us minus 5. 11 minus 6. This will be giving us somewhere 6 minus 6, and that will be 0 equals 0. It means the factor of this 1 can, if x assume 1, it makes this polynomial to become what? 0. Meaning x minus 1 become the factor of this polynomial. So we can say that x minus 1 is what? A factor. Why is it x minus 1? Don't forget we use a positive 1. So from here, if the whole of this equals to 0, x will be equal to 1. So that is the factor that can divide this. So I have my x minus 1 dividing x to the power 3, 6x squared, 11 minus what? 6. We want to divide. We are looking for x, so we need to be able to factorize this. So when x divide this, it gives you x to the power what? 2. When you multiply, you have x to the power 3 times this will be minus what? X squared. Let's subtract. This will be 0. It's going to be minus 6 minus minus 1, as in this case. And that will be plus. So minus 6 plus what? 1. We have minus 5. Good. So here I'll be having minus 5x squared. I think our 11 is having x. So then we have plus 11x minus 6. Okay, so for the second line, from here we are also going to divide negative 5x squared by x. And that is going to be negative 5x. Why? Because when you put x here to divide, there are 2 of the x squared. It will cancel 1. So if that is the case, we go back and multiply the quotient and the divisor, and that gives us negative 5 of the x squared. Negative times negative. I believe that gives us what? Positive 5x. So now let's perform our subtraction again. This is going to be minus 5 minus minus 5. It cancels to 0. Here is going to be 11 minus 5. That gives us 6 of the x. Then we bring down minus 6. This x will in turn divide this. Going here, it will be only plus 6 times. 6 times this will be 6x. 6 times this will be minus what? 6. Let's perform. 6 minus 6, 0. Minus 6 minus minus 6. That will be 0. So we are going to have 0. So it means there is no remainder if x minus 1 divide this polynomial. So now what do we do? For us to get our solution, it means the divisor, which is x minus 1, multiplying x squared minus 5x plus 6. If you multiply this and this, you get back your dividend. So this will still be equal to what? 0. We are only replacing our polynomial by this factorization. We are trying to factorize and get the values of x. So we can see this is a constant, which I can see one term. So this is either equal to 0 or this right here equal to 0. But you can see this is a quadratic equation. Looking for factors of 6. When you add, you get a minus what? 5. So if I have minus 2 minus 3. By multiplication, it gave me 6. By addition, it gave me this. So it means I'll only be having x minus 1, x in the first bracket. Don't forget, it will be in 2 brackets. The second will be x. What are the factors? The factors are minus 2 and minus 3. If you expand this, we get back the top. So there are 3 brackets that are multiplying, and all of them equals 0. It means either this is 0, or this is 0, or this is 0. So simply put, x will be equals to this being 0 will give you 1. Or, okay, let's take it step by step. X minus 1 equals 0. Or x minus 2 equals 0. Or we have our x minus 3 equals 0. And in the case of this, x will be negative 1 transpose give you 1. Or negative 2 transpose give you what? Positive 2. Or negative 3 transpose give you what? Positive 3. So in this determinant equation, or better still in this 3 by 3 matrix, the values of x that will make the 3 by 3 matrix to be the determinant of the 3 by 3 matrix to be equal to 0 will just be 1, 2, or 3. Any of them, 1 will make the determinant to be 0. 2 will also make it, and 3 will also make it. I will indulge you to substitute the values of 1, 2, and 3 into the main determinant 3 by 3 matrix and see if you perform the determinant, you will get 0 at the end. Thank you so much for watching. Like, share, and comment. Don't forget to subscribe if you are new. Bye bye.